Okay, here we go. 2.16 could be our last section of the unit. Wow. 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 All right, so let's read through the state lottery results problem here. Go ahead and take a quick little read of that. Here we go. So we want to. Oh, wait, I forgot to. Hold on 1 second. Anyway, back to it. So we want to find and interpret the probability of winning at least $200 by playing this lotto game one time. Okay. So what does that mean? Great question. At least $200. So I think about. I'm looking at this section right here. Look at there. What's the probability? The probability is 0.000. Hold on. 0.00164. 0.000164 of winning $200. All right. That's very, very low chance. Okay. It's a very low chance of doing that. There's a probability that you win something. So at least $1. Well, there's a 0.0833 chance, or about 8 to 9% chance that happens. All right. This is a very low number. This would be about, if I multiply it, that's about 0.0164% chance. Multiply this number by 100, move the decimal place over twice. All right. But hey, winning the lotto would be kind of a big deal. So I'll be honest with you, I play every once in a while. Why not? Why not? Why not? Why not? Never know. Never know what could happen. So we talked about probability a little bit in Unit 1. All right. So what we're focusing on today is theoretical probability. We talked about experimental probability in the past, and I hope to make sure that we understand the difference between the two by the end of this lesson. That is going to be our goal for today, or one of our goals today. Then how to calculate theoretical probability when all outcomes are equally likely as well. All right, so here is theoretical probability. All this good stuff. Probabilities between 0 and 100. The probability of event can be written like this. Probability is between 0 and 1, or it can be written as a percent. Okay. A lot of times we'll write probability as a fraction. You'll see a fraction. Okay. If I ask for percentage, obviously we know that 0% is impossible. 100% is a certain thing. So theoretical probability is define theoretical probability. We put the number of outcomes we want over the number of possible outcomes. When we're listing outcomes for an experiment, we're finding the sample space of our event. All right, that's a lot of mathematical words. Okay. Excuse me. Sorry. Sorry. So our sample space, if you look at this example, rolling a die, I want to hit a 5. I have a 1 in 6 chance of rolling a 5. Okay. You've probably seen this notation before. Maybe you're going to have some Algebra 2 memories, or maybe not so great memories. We're going to start off with number 2, which makes no sense, but we're jumping to it. So if you look at this, suppose in a bag you have 5 blue, 14 red, and 9 green marbles. All right, so that's a total. What is that? 5. That's 28. 28 marbles. Okay, what's the theoretical probability of picking a blue? Well, it's 5 out of 28. Okay. What's the theoretical probability of picking a green? 9 out of 28. And that's it. That's all you have to write. Okay. Theoretical is what could happen. Experimental is an event that already did happen. Experimental meaning I did an experiment on it. Theoretical is, hey, I'm going to predict what I could potentially, the chances I could potentially have. Doesn't necessarily mean that's going to be the outcome. That's the biggest difference between the two. Okay. Theoretical theory. It's a theory. I have a theory that this is going to happen. Find a theoretical probability of getting a sum of 5 on the 2 when 2 dice are rolled. 2 fair dice are rolled. So the book went out all the possibilities. Now, I wouldn't ask you to do this on our assessment. I wouldn't ask you to sit there and write out all these possibilities. That's 36 possible outcomes. That's a lot to sit there and have to write that by hand. There are different ways to do that. The type of problems that we're going to be focusing on are not going to have you do this. Okay, I'm not going to have you focus on that. All right, but you'll see here, because the book did this for us, there are 4 possible outcomes, 4 possible times that I could get a 5, or a sum of 5, excuse me, which means that I have 4 out of 36, which is 1 out of 9. Always reduce if you can. Always reduce your fractions when possible. So the book also goes in this huge long explanation about something and yada, yada, yada. Most important, most important part was the last paragraph, to me at least. Okay. The probability of an event occurring and the probability of an event not occurring must sum to 100% or 1. So, for example, if you think about the weather, there's a 70% chance of rain. That means there's a 30% chance that it won't rain. Okay? If a probability of getting a sum of 5 is 1 out of 9, then our probability of not getting a sum of 5 is 8 out of 9. If the chance that I get an A in this class is a 30%, then the chance that I don't get an A would be a 70%. If the chance that I, have a ham sandwich for lunch would be a 90% chance, then the chance that I don't have ham on my sandwich for lunch would be a 10% chance. All right, so their sum is always going to be 1. All right, that's pretty important. That's going to come up more and more. Okay. The last problem makes an important point that experimental and theoretical probabilities for the same event can and often are different. The experimental probability tells us what percent of the time something actually happened, whereas theoretical probability tells us the percent of what we expect to happen. Usually, the more times an experiment is conducted, the closer the experimental probability gets to the theoretical probability. All right, so experimental is something that really occurs. Theoretical is something that could potentially occur. And I think you guys kind of got that. That was all about number 3. We skipped number 3. That one, I don't see us doing anything like that. So I'm going to go number 4. Suppose there's a raffle with numbered tickets. Your ticket is randomly drawn from a hat. Your number is number 121. Find the probabilities, find all the following probabilities, state your answer as a fraction, and as a decimal, and as a percent. So I have 1 ticket, there's 200 tickets. I have a 1 in 200 chance of winning. Okay? If I do 1 divided by 200, what did I get? 0.005. That's right, yeah. Which is 0, if I multiply that by 100, a 0.5% chance. Very small chance of winning, less than 1%. That stinks. Guess what? If there's 400 tickets, my theoretical probability tickets, so it's 0.0025, which is 0.025% chance of winning. That stinks. That really stinks. If there's 1,000 tickets, holy buckets, my chance is not going to be good. 1 out of 1,000, because I only have 1 ticket. My recommendation, buy more than 1 ticket. Obviously, you can see that right here. Try to buy 2. Heck, buy 2, your chance doubles. Maybe buy 3, your chance will triple. Maybe buy 4. Guess what will happen? Your chance will quadruple, obviously. And guess what? If you buy 10, your chance will increase by 10. I don't know what the quadruple form of 10 is, but that's what will happen. I'll have a 0.1% chance of winning. All right, that's a less than 1% chance. That stinks. Not a big fan. But I do like participating in the 50-50 raffle. I'm a big fan of that. I always try to get tickets whenever I go. I think it's for a good cause. Let's keep going. What happens to your chances of winning as a number of tickets increases? Well, my chances of winning, I already talked about that. Our chances decrease. And why is that? Well, there's just more. B/C says means because. Yeah. Our denominator increases. If 150 if 150 tickets were sold in a raffle, how many tickets would you need to buy to have a 10% chance of winning? So I want to figure out, well, what is 10% of 150? Okay, what is 10% of 150? Well, 10% as a decimal is 0.1. I did 10 divided by 100. That gave me 0.1. Okay, so I'm going to take that 0.1 and I'm going to multiply it by 150 to get 15. All right. I could have also divided by 10, but I like to multiply by a 0.1 because that's going to change. Like if I said, if you want to have a 33% chance of winning, okay, what would happen? I would do 0.33 here. All right. So I would have to buy 15 tickets to have a 10% chance. Not too bad. When your probabilities are small, it's helpful to use place value to interpret the meaning in a meaningful way. For example, 0.25% is 0.0025 or 25 out of 10,000. Yeah, that's just a nice little anecdote in there for you. All right. Wish we knew. That's it. We're going to do the last one together as a class. Quick lesson. We'll do the connection about dartboards as a class. There you go.